right, so we have the last part of Unit 7, Part 2. We have inverses because logarithms and exponents are inverses of one another. So we're going to go all the way back to like one of the very first units we had that taught us how to find the inverses of equations. Same 4 steps, but we kind of do something a little bit extra because of these weird log exponent rule things. So just one extra like little step in there, but we don't actually have it written down as a step. We just in practice are going to do it every time. So we have 4 steps. You're going to first change f of x to y, and then switch your x and your y. Oftentimes, now that we've done inverses so many times, often it is perfectly fine for you to do those 2 steps together, where you change y and switch it at the same time. I often will do it in class, or when you see me do it in a key or something, I'll often do that. So if you want to combine some steps, you can go ahead and combine those steps. Then you're going to solve for y. That kind of has a special piece to it this time, because as far as solving for y follows a specific order that you need to go in. And then step 4, change f inverse, or change y back to f inverse of x. All right, so first example, I have f of x is equal to log base 4 of x. So step 1, rewrite f of x as y. Step 2, switch them. Okay, now I need to get y by itself. For me, it is really hard to see how in the world would I get y by itself. So I'm going to switch it, and I'm not switching the x and y. I'm just putting all of the y stuff on the left side and all the other stuff on the right. Because then I can kind of see a little bit better that what I need to do is I need to do my e. Okay, so once you get the log part by itself, and all you have is the y or the argument. You have your base and your argument. That's all you have. You're going to do the e. It's really hard, and I know Coach Torres is the same way. It's really hard for us to do the e backwards. So we're very just concrete in our thinking. We have to move the y part to the left so that we can do our e. So what does that mean I have? I have 4 to the x is equal to y. Y is by itself. So now you just change y back to f inverse of x. And that's it. That is the inverse. Easy enough. Inverse of a log is an exponential. Inverse of an exponential is a log. So second example, I have f of x is equal to log base 5 of x minus 3. Step 1, rewrite. Step 2, switch them. Now I'm trying to get y by itself. Now so I'm going to add 3 because I don't just have the log base 5 of y. I don't have the log in the argument by itself. I have that that minus 3. That minus 3 is not part of my argument, so I need to move it. How do you move a minus 3? You add it. So I have x plus 3 is equal to log base 5. Again, for me, if you can do this, more power to you. I can't. My brain is so ingrained on doing an e. I need that log base 5 on the left, and I need the x plus 3 on the right. Again, if you can do your e backwards, high five to you. I can't. So I'm going to move it to the other side. Now I'm going to do my e. So I have 5 to the x plus 3 is equal to y. Again, going with the order. The e tells you the order. 5 is where I started. X plus 3 becomes my exponent. And y is what the output is. Y is by itself. And so I have I have 5 raised to the x plus 3 is equal to f inverse of x. If you want to write f inverse of x first, that's totally fine too. I just didn't want to rewrite it again. So again, I have a minus 3 in my original, a plus 3 in the inverse, makes sense. A minus 3k makes sense that it would be a plus 3h. All of that is flipping. That's what an inverse does. It does the opposite operations. Bases are going to stay bases though. So I have log base 2 of x minus 3. Rewrite and flip. So again, I am stuck in knowing what to do. All I have is my base and my argument. So in order for me to be able to do my e and have my brain understand what it's doing, I'm going to rewrite my log on the left and my equals on the right. Now I can do my e. So I have 2 to the x is equal to y minus 3. Now this is the first time where we've done the e and the y isn't by itself after we do the e. It's no big deal. How do you get y by itself? You add 3. So I have 2 to the x plus 3 is equal to y, which I rewrite as f inverse of x. Just going through all of my opposite operations, I originally had a log, inverse would be exponential. Bases are going to stay bases though. I was originally subtracting 3, I am now adding 3. It was a minus 3h, and now it's a plus 3k. Makes complete sense. Everything switches when you're doing inverses. All right, the last example where we were starting with a log and going to exponential. Rewrite, switch. Now, my log is not by itself. I do not have my argument and my base by itself. So I'm going to subtract the 2 first, and I have x minus 2. Now my log is by itself, but I cannot, because I'm just high five to you guys if you can do it. I need to move it. I need to switch the sides. I need to put that log in the argument on the left and the equals on the right. Now I'm going to do my e. So I'm starting with my base. I'm starting with my 3, going to x minus 2, and then finishing with an y plus 1. Then I subtract 1. So I have 3 raised to the x minus 2 minus 1 is equal to y, which I would then just rewrite as 3 raised to the x minus 2 minus 1 is equal to f inverse. Again, just making sure all of this stuff matches. Bases are going to stay bases. I originally started with a log. My inverse would be an exponent. My original is adding 1. My inverse is subtracting 1. My inverse is adding 2. My original is adding 2. My inverse is subtracting 2. The plus 1 was an h. The minus 1 is a k. Makes sense. The plus 2 was a k. The minus 2 is now an h. It all makes sense. All right, so now we've talked about where you start with logs. So now we're going to start with exponents. The rules are the same. You're going to rewrite as a y, switch it, and then get y by itself. But again, how do I bring down that y? Is I've got to do an e. Okay, I've got to do an e, and it's really, again, same thing with me and with logs and with exponents. I cannot do an e backwards. It's still loop-de-loop, yes. I know lots of you are calling it loop-de-loops instead of e's. To me, it's an e, and I can't do e's backwards. So I'm going to switch the side. So I'm going to put 3y is equal to x on that side. Now it makes sense to me on how to find it. I do my e. I start with my base, do my e. So that is 3 log base 3 of x is equal to y. 3 is where I started, so bases stay bases. Argument is what it equals, and then my exponent is now what it equals. Now my y is by itself. I didn't have to do anything else, so I just need to write it as an f inverse. Again, make sure I have opposite operations. Originally it was exponential, now it's logarithmic, check. Bases are going to stay bases. There was no h or k on either one of those, so it makes sense that that's not still there. Another example, f of x is equal to 5 raised to the x minus 9. Rewrite, switch. If you want to put those in the same steps, more power to you. Y is not by itself, and it's part of an exponent. I am going to go ahead and switch it, though, because then it's a little easier for me to see it. You don't have to switch it right now. You could, what I'm going to do next, add 9. And then switch it, you're going to eventually get the same thing, okay? My y is not by itself. I don't just have the exponential part by itself. So I need to add the 9. So I'm going to get 5 to the y is equal to x plus 9. So now I have my base and my exponent. That's the y, which is great. Go ahead and e it out. Log base 5 of x plus 9 is equal to y. Now the x plus 9 is an entire piece. So that entire piece needs to go into parentheses because it's going to be an h. It also makes sense after I rewrite it because the minus 9 was a k, which means the plus 9 needs to be part of my h on the inverse. Remember, everything flips. Your x and your y flip, your h and your k flip. So my minus 9 that was my k on my exponential is going to become a plus 9h on my log. So how do I make sure it's a plus h? I have to make sure it's in parentheses. So this again is log base 5 of x plus 9, all in parentheses because it's all there, is equal to y. And that's your f inverse. Another example, I have f inverse of x is equal to 2 raised to the x plus 1. Rewrite, switch. I can't see it, so I'm going to flip it around. There was no adding or subtracting happening outside of that exponential part, so I'm just going to go ahead and switch it, and I'm going to do the e. So this is log base 2 of x is equal to y plus 1. That entire exponent is now what it equals, and that entire exponent was y plus 1. So that plus 1 gets to tag along with the y. I don't want y plus 1, I just want y, so I need to subtract 1 from both sides. Now this becomes the k, which again makes sense when you understand what an inverse does. If my original was an h, which it is up there in my exponential, that original was a plus 1h, it makes sense that that needs to be a minus 1k in the log function. H's and k's switch. So I'm not going to put it in parentheses because the parentheses were established when I made the e. The only thing that was there when I made the e was the x. So the minus 1 goes after it, and it does not include parentheses, and then I would just write it as f inverse of x. Bases are going to stay bases. My base 2 stays base 2. I have a plus 1 original, minus 1 inverse, makes sense. Plus 1h, minus 1k, makes a lot of sense. Last one, I think, we'll find out. I have f of x is equal to 0.25 raised to the x plus 3 minus 2. Rewrite, switch. My exponential part's not by itself. I don't just have a base and an exponent. So I'm going to go ahead and add the 2, which is going to give me x plus 2 is equal to 0.25 raised to the y plus 3. All I now have is the base and the exponent. So I'm going to switch it so that I can do my e right. Do my e. So I have log base 0.25 of x plus 2 is equal to y plus 3. Okay, so my base was 0.25, it stays my base. The next thing I hit was x plus 2, so the x plus 2 is my argument, and the y plus 3 is what it equals. Y is not by itself, so I need to subtract 3, and I have log base 2.5 of x plus 2 minus 3 is equal to f inverse of x. And all of this makes sense. Originally, mental check, I originally had an exponential, I finished with the log. Originally adding 3, and it was a plus 3h, a minus 3k in my inverse. My minus 2 original, my minus 2k in my original makes sense that it's going to be a plus 2h in my inverse. And that is inverses. So